Hi, in this video I will be presenting about survival analysis, and I will explain what survival analysis is and show you the result from two different methods and compare them at the end. And so let's begin with what actually survival analysis is. Survival analysis is a statistical method that studies the time until a specific event happens, and in the medical research the event is often death, but it can also be recovery from an illness or relapse of disease in some cases. And in this task I used a lung cancer patient data set, and the goal of this assignment or this task is to understand how long patient survive after entering the study, and which factors affect the risk of dying. And for this I use two different methods: Kaplan-Meier estimator and Cox proportional hazard model. And let's begin with Kaplan-Meier. And in simpler term, Kaplan-Meier estimates the probability that a patient is still alive at any given point in time, and it works by looking at when event actually happened in the data, and in our case when the patient is dead or died. Every time a death occurs, the survival probability drops a little, and this gives us a shaped curve that goes downward over time. And one more important concept here is censoring. Not all the patient or not all the person included in the studies tends to remain, and sometimes they can leave before the study ends, and we do not know what happens to them. And for those patient or for those cases, Kaplan-Meier still uses this patient in the analysis up till the last point they were observed. And another thing is Kaplan-Meier is called as a non-parametric method. It is because that it does not assume any specific distribution for the data, whereas method like exponential or Weibull requires us to assume the survival times follow a particular mathematical shape. um, Kaplan-Meier does not make that assumption, and it relies entirely on the observed data, and this makes it more flexible, and it is usually the first method that we or analysts use when exploring the survival data. Okay, let's look at this survival curve and try to understand it. And at time 0 all patients are alive, so the probability here is 1, and after this the curve then drops as patient die over time. And the steepest drops happens in first between 200 to 400 days. This tells us that the most critical period for this patient is roughly the first year period, and after first year period after entering the study, and the median survival period, or until when the 50% of the patient manage to survive, is around 300 days. uh, it also means that after the 1 year period or after 300 days 50% of them already died. And after around 600 days, and the curve flattens, and this happens because fewer patient remains in the study, and so is death has a smaller effect on the estimated probability. And we can also see the confidence interval getting wider in this region, which reflects more uncertainty with smaller numbers. And the second method is Cox proportional hazard model. While Kaplan-Meier just shows us the overall picture of the survival, the Cox model goes further, and it lets us study how specific variable like age, sex, or health status affects a patient risk of dying. And the model produces a coefficient for each variable, and positive coefficient here means the variable increases the hazard, and hazard or that increases the risk of death, and the negative coefficient means that it decreases the risk. And we also look at the hazard ratio, which is simply the exponential of the coefficient. and a hazard ratio greater than 1 means that the higher risk, and less than 1 means lower risk. It is easier to interpret in practice, and in my result the two variables were significantly sig- in my result the two variables seems to be statistically significant, and the first one is sex, and the another first one is sex. Here female patient had a coefficient of negative 0.63 and a hazard ratio of 0.53, and this means that the female patient had approximately 47% lower risk of death compared to the male counterparts or male patient, uh, and after controlling for other variables this is meaningful difference. And the second one is ECOG score. This score measures how well a patient can carry out daily activities, and the score of 0 means they are fully active, while higher score means worse condition. The coefficient was positive with a hazard ratio of 2.10. This means that for each 1 unit increase in ECOG score, the risk of death roughly doubles. And the other variables is Karnofsky score and weight loss showed some effect but were not statistically significant in this model. And the main assumption of the Cox model is called proportional hazard, and this means that the hazard ratio between two groups must stay constant over time, and they should not have roughly half the risky. um, uh, for example, if female patient have risks of have the half the risks of male patient at day 100, they should also have roughly half the risks at day 300. And the relative difference should not change or does not change, and this assumption is important because the entire model is built on it, and if it is violated, the coefficient might not accurately reflect the true relationship in the data. And so how do these two methods compare? Kaplan-Meier is descriptive. It tells us what survival pattern looks like over time, and but it does not tell us why. It treats all patients as one group, and then mm, or it must split them into a smaller number of groups. And the Cox model is explanatory. It tells us which specific variable drives the risks and by how much, and it can handle multiple variable at once and gives us a much more detailed picture. And in short, Kaplan-Meier shows us what happens, and the Cox model helps explain why it happens. And you might also wonder why did not we use parametric model like y-wolf or exponential. And the reason is that parametric model requires us to assume a specific distribution shape for the survival time. For example, the exponential model assumes the hazard is constant over time. If the experiment is wrong, the result will also be wrong too. And with real patient data we often do not know the true distribution, so Kaplan-Meier and Cox model are more flexible. They do not impose those assumptions, and this is why they are typically used as the starting point in the survival analysis. And in summary, I use Kaplan-Meier to estimate the overall survival curve, which showed the median survival time was around 310 days, and the risk was highest in the first year. And then I use Cox model to identify the that sex and ECOG performance were the most significant predictor of survival. And both methods are non-parametric or semi-parametric, and which makes them suitable for medical data when the distribution is unknown. Thank you.